Okay, friends, welcome back. We're going to look at lesson 6 of word problems. And so today we're going to do a little review of our what we've learned so far about adding coin questions. So here we go. I want to make sure that I have my trusty pen with me. So let's take a look at this one. A boy has 7 less quarters than dimes. So the way I'm going to start every single word problem is start with my variables. So I can see that I have dimes and I have quarters. Okay, and I know that I'm going to call dimes D because quarters are being compared to dimes. So if I go dimes minus 7, that's how many quarters I have. Okay, so that's my first part. So we're going to do that every single time. Now, here's what I also know. I know that 10 cents is how much a dime is worth. And if I go 10 times D, that will give me the total value of my coins. So if I had 3 dimes, I'd have 30 cents. Or if I had 7 dimes, I'd have 70 cents, or 7 times 10. We don't know how many dimes we have, so I'm going to call it D. Now, quarters are worth 25 cents. And I could go 25 times Q, or I could go D minus 7. And I'm going to choose D minus 7 because I want to have only D's in my equation. Now, here's the next part. Notice that this is $4.90. So what I'm going to do is I'm going to call this 490 cents. So I can call this 25 rather than 0.25 and this 0.1. If I have the decimal point there, I need to put a decimal point here and here, and I don't want to do that. So at this stage here, I think most of you are very good at solving this. This would be, we can expand this out. You all mastered the last chapter. So it's going to be 10D plus 25D minus 25 times 7 is 175 equals 490. Now, I'm not going to finish this problem here for you because I know you know how to collect these terms, take the 175 to the other side and divide by 35. But you should know that when you do this well, when you do this well, there'd be 120 quarters. Okay? And of course, by 120 quarters, I mean 12 quarters. So that's a typo. And we're just going to cross out that 0 there. So that should be 12 quarters and not 120 quarters. That's way too big. Okay, so that's what we did last day. Okay, now what I'd like us to consider is today's challenge. And today's challenge is no doubt a challenge. So what we're going to do is a little warm up here. There's a collection of dimes and nickels. There are a total of 20 coins. So one way of writing this would be to say that nickels plus dimes equals 20. So if we said there's n nickels, how many dimes would there be? Well, dimes would actually equal 20 minus n. So we just say 20 minus n. Oops, we'd say 20 minus n. That's exactly how we'd write it. Okay, another way to think about this is if you had 5 nickels, well then you'd obviously have 15 dimes. And how did we get 15? Well, we know that there's a total of 20 coins. So if you go 20 minus 5, you get 15. And if this was 7, then of course this would be 13. And since we don't know how many dimes we have to call this n, so it's going to be 20 minus n. Let's try this again. Why don't you try this one on your own? There's a collection of loonies and toonies. There's a total of 100 coins. If there are L loonies, how many toonies are there? Well, once again, loonies plus toonies has to equal 100. So if we solve for t here, t's got to equal 100 minus L. And that's all we got to say. So let's go ahead and see if we can play around with this one. Victor has a bunch of quarters and toonies. Quarters. So this is a quarter. This is a toonie. A quarter's worth 25 cents. A toonie is worth 200 cents. Okay, we don't know how many of each we have, so if I called this Q, then I would need to call this, well remember, it's Q plus T equals 82. So if we solve for T is going to equal 82, subtract Q. Okay, and now when we sort of try to put this all together, we know that we're going to have 25 cents times the number of quarters we have, Q, plus 200 cents multiplied by 82 minus Q. Okay, and that's going to equal 109, 10,975 cents. So if you want to call this, 0.25 and $2 and 25 hundredths of a dollar, or 25.25, then we could call this 109. But I prefer to not use decimals and call this 200 and call this 25. Okay, and from here what we do is we'd expand this out using our calculator. That'd be okay to do, and then finish the problem. Okay, so I'm going to scoot through this next review, and this just talks about different ways of setting this up. So I'd love for you to sort of walk through this on your own time. But I'll kind of do a quick one for you. Victor has a bunch of quarters and toonies, and John said totals this. Are 82 coins in total. How many of each are there? Well, you could say that it's 200 cents and 25 cents. This would be T, toonies, and 82 minus T. Notice on the previous slide we did it in a different order. That'll be totally fine. It works both ways. And so we'd expand that all out. Now, if we wanted to do it in dollars, that's the point that I was hopefully making. And notice that this is 25, this is 0.25, this is 200, this is T, this is 109 and 75 cents. This is all in cents. So it's really sort of up to you. Okay, let's try this problem. Please pause this video, give it a try, and then we'll try it together. Okay, thanks for pausing the video. I hope you put at least 5 minutes into thinking about it before you're listening to me. So a collection of dimes and nickels, I missed the D there, is worth $8. So I know that dimes plus nickels equals $8. And I am going to call this 800 cents. Okay, that's what I'm going to do. So if we said we had D nickels, then I hope it's fair to say that N would be, oh geez, I'm misreading this question. I am definitely misreading this question. Definitely misreading it. Poor start. Wow. A collection of dimes and nickels is worth 8. There are 2 times as many nickels as dimes. Okay, this is not what I expected this question to be. I was not thinking. Okay, so there are 2 times as many dimes as nickels. So there's many times nickels as dimes. So I'm going to call D dimes, and nickels is going to be 2D. Okay. I know that dimes are worth 10 cents. So if I go 10 times dimes, because that's 10 cents, plus 5 times the number of nickels that I have, that equals 800 cents. Okay, so this isn't a new problem. This is kind of like the last day's lesson. So anyhow, this would be 10D plus 10D, collect like terms and solve. I think you can do that quite well, and I'll just see what the solution here looks like. So I would have made this 5, 10, and 800, but it should work. It will work out either way. Okay, so ultimately we have 40 dimes and 80 nickels. Okay, here's another example, and this one can be quite tricky. So what I'm going to do is I'm going to walk you through this one here, okay? So this is the situation. Ticket sales at the school concert totaled $2,520, $2 for students and $4 for adults. Every seat was filled in the auditorium, which means 1,000 people attended. All the ticket stubs were thrown out. How many students attended? Classic. This is a great example. So first things first is we know that there's adults who came, and so we could also say this up above, that we know that adults plus children equal 1,000, or students, I should say. So is it safe to say that adults equals A and the children are going to equal 1,000 take away A? So that's where that came from. Now we know that the total revenue is going to equal $4 times the number of adults plus $2 times the number of kids. And so then we're going to have this equation, and we can multiply that through, which we'll do. And from here, I think you can finish it from here. So we're going to collect like terms, which we're going to do up here. So those will come together. Then we're going to subtract 2,000 from both sides. Then we're going to divide by 2. And then the moment of truth. What the heck does A equals 260? Is that a dollar amount? What is that? Well, I'm just going to go back and try to look for A. Oh, there's A right there. A is the number of adults. Perfect. So that's how many adults came is 260. Well, how many children would have shown up then? Well, there's another A. So if I just go 1,000 minus 260, that is how we'd find the total. So now we know. Okay, let's take a look at this next problem. This looks kind of tricky. This problem, set up this problem in more than one way and solve each method. Okay. Okay, so here we go. There's 475 people at a play. Admission was $5 for adults and $2.75 for kiddos. Receipts were $1,947.50. How many adults and how many children attended? So pause the video, give it a try, and we'll chat about it. So one statement we could say is that adults plus children, and this is the number, is A plus C equals 475, which would mean that C could equal C, and A would equal 475 minus C, because of course if you take C away from that, we're good to go. So is it fair to say that we could say that $5 times adults plus $2.75 times children equals $1,947.50. And of course what we're going to do here is we're going to sub 475 for A. Now at this point here, we're back to where we've been very successful. We're going to expand everything out. So that's what I did here. We're going to collect like terms. We're going to divide. Oh, so we collected like terms here. We subtracted 2,375 from both sides, and then we're going to divide by 225. So it looks like C equals 190, and C was children, and then adults would be 475 minus 90. So I hope that helps. I know I'm going through these fairly quickly, so don't worry about rewatching this video. But more importantly, going through the slide deck on your own and trying it on your own is so important for learning. Okay, so that's the lesson. I hope that helped you. Come on in and see us if you need anything.